مسائل حول رؤية الهلال لمحمد زمبري زين الدين.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Thank you, Mr. Chairman. Distinguished and honorable participants, and to all the people in this hall. First and foremost, I would like to convey my warmest regards or thanks to the ICOP committee for inviting me to share our experiences in Malaysia about sky illumination for lunar crescent visibility in Teluk Kemang, Malaysia. I have actually two papers, but I have to combine the two papers. One is on sky illumination, the other one is on atmospheric refraction. So I will try to go brief. Okay, the first paper is you can see on the screen the value of sky illumination for a day in which lunar crescent was seen with naked eye and theatre lights. So, from 1972 until 1999, the lunar crescent observation were observed with naked eye and instrument for surveying called theatre lights. And since 2000, telescopes has been used for observation. So here I just will say that we have performed sky illumination measurement using a light meter from 2007 until 2009. It's about 2 years. And the data was checked with moon calculator software, and the analysis of the values then were correlated with relative attitude and sun depression angle. So we found that the range of sky illumination for lunar crescent to be seen is about 2.95 lux to 92.80 lux. And for the highest sky illumination value, we find that the value is 92.80, and the relative altitude should be greater than or equals to 5 degrees. So the moon the crescent should be 5 degrees above the horizon. And the depression angle, that is a solar depression angle, should be equal or less than 0.5 degree. So this is just an introduction. I just skipped the introduction. I think everybody understand more better. And then this is still about this criteria to find minimum condition for moon crescent to be visible by different approaches. You can have a theoretical approaches, you can have or empirical approaches, as well as observational approaches. So what we are doing here is on the observational part. So the sky illumination condition is measured during the day of the moon crescent expected to be visible. So regarding on the previous study, which has resulted so much different criteria, but one of the most important criteria is the contrast. So how bright the background of the sky that crescent is visible, whether with naked eye or with telescopes aids. So this is a view of Teluk Kemang in Malaysia. You can see the sun is setting and the sky is considered to be clear. And we also have condition where the sky is filled with cloud, and you can still see the sun just hitting the ocean level. So basically, if the depression angle, if the solar depression angle is larger, then we can expect the sky is much darker. So there is a high or most likely chances to see the crescent moon. Okay, so the sky illumination observation were just using a light meter and were performed at Teluk Kembang, one of the 29 sites of crescent observation in Malaysia. So for the 2 years, we collect every month, we go and observe the crescent, and at the same time we measure. So this is one of the very good sky at Teluk Kembang, sunset at Teluk Kembang, cloudless sky, so you don't really see much a cloud there. And this is not a good scenario, so you can see there's a lot of band of cloud near the horizon where the sun is setting, and there's a sea. So this is the location for our observation. So this is what we call Baitul Hilal in Malaysia. But this location now is under construction to house 60 centimeter diameter telescopes at this location. So this is while we do the sky brightness measurement, we also observe the Hilal using a telescope and a piggyback telescope, and we capture the images from the telescope into the camera, and then we just print the images. So this is the very simple methodology. The elapsed time for data, in this case, it is opposite. Before the sunset, we said it positive value, but when it goes to after sunset, it will be positive value. Before sunset, positive values. After sunset, it will be negative value. So figure 1 shows a gradual decrease in the sky illumination with respect to elapsed time. So you have this sky illumination flux on the y-axis, and the elapsed times on the x-axis. And this is the best data that we have, because during this period, the crescent were visible throughout the thing until the crescent set. So this is why we use this as our calibration. In fact, we have used 13. We have taken 13 data sets for this sky illumination, but this is the best data that we have. So this is one of the data. The top one will show the sky illumination with a local time. The down one will show you the solar depression angle from the horizon to below the horizon. So you can see this is all the data that we have obtained, but some are not that good because of the cloud and so on. So based on this data, and then we just try to fit all the previous data that we have in our record from 1972 until 2008 in Malaysia, where the crescent sighting is positive. We've tried to fit into our sky illumination graph, and that's why we have the results. Basically showing us that the maximum sky illumination is about 92.80, and the minimum is about 2.95. So below the minimum, of course, you can see the crescent if it is visible. So here is from the hypothesis, it's known that the lower the salinity of the sun depression angle, the sky illumination will give a lower recording, as the sky illumination is greatly affected by the sunlight. Okay, so I have about 5 minutes, thank you. Okay, and I meet the value of 4.33 to 30.6. Therefore, what we have here is the results, yeah, to show that with sky illumination of power 52 or to 4, you have about 0 to 1 minus 1 sun altitude. Okay, so this is the result finally to show you all. I'm not able to show it. But so the next one is about refraction. And it's very critical for us to determine the position of the crescent, because near the horizon, the refraction is much more obvious compared to at zenith. So what we basically do is we have the Department of Survey and Mapping from Malaysia to assist us in this observation. So you can see that the light should be straight, but because of the refraction, you can see the bending there. And this is how we do our model for determining the difference between the actual position of the crescent and the apparent direction of the crescent due to refraction. So the different R is the refraction, is basically on arc minutes distance. So if you look carefully, these are images of the sun which rarely appear green flash before the sunset. Very rare this type of thing happen, but if this happen is because of the refractive index differences in the atmosphere. So this is a typical atmospheric absorption, transmission based on wavelength and absorption. And this is, as you can see, from Flagstaff, Arizona, May and June 1976, how the extinction take into consideration. And so you can see the major contribution to the uncertainty and reflectivity are the uncertainty in measurement of temperature and pressure. So we do all the measurement. And this is one of the graphs to show. And this is different in sunlight day due to refraction. Yeah? At equinox, at winter solstice, at summer solstice. So the measurement is very simple. A survey here do this measurement for the position of the sun before setting at the horizon. And this is a total 10 years data that we have collected from 2000 to 2009. So from here we do the fitting, and we find that the minimum refraction is 35.5 arc minutes, and the maximum about 38.3 arc minutes, compared to the standard 34.5 arc minutes, which is set by American condition as the atmospheric refraction is actually a local condition. So we have to use our Malaysian condition to suit our calculation for the position of the crescent and also for Maghrib prayer. So these are the images of the Hilal that we captured from the 10 years study. And this is the on last year. We captured all the images of the Hilal. And this is the Hilal that we captured using image processing technique, as Martin has mentioned. So how we can process, and we can see a very thin crescent there. And that's all for my presentation. Thank you very much.
More, thank you.